Hello everyone. So hopefully this video helps you with your Google slide assignment today. And so your goal is to look at these two pairs of triangles and determine if they are similar. So how do you know if triangles are similar? Well, one way is making sure they have two angles that are congruent. So this angle is congruent to that angle, and this angle is congruent to that corresponding angle. Therefore, these two triangles are similar. That's basically the angle-angle similarity. So let's go ahead and look at these two triangles. All right, well, we know right off the bat that this is 90 degrees and this one is 90 degrees. So we know that two of our angles are definitely congruent. Just by looking at it, we know that. But now, is this angle the same degrees as this one? And it's off to a little bit, it needs to be over here, but whatever. And so we're going to use triangle sum theorem, and that means that triangles add up to 180 degrees. So we know if we add this plus this plus this, it must equal 180. So I'm going to go ahead and start with 180 degrees. Then I'm going to subtract 90. What I'm trying to do is figure out how many degrees is this angle right here. And so we know 180 minus 90 is 90. And then we're going to subtract this degrees, 31. And what do we get? We get 59 degrees. So we know this angle measures 59 degrees because 59 plus 31 plus 90 has to equal 180 degrees. And since this is congruent to this, and this angle is congruent to this one, these triangles are similar by angle-angle similarity. Okay, so let's look at this one. Well, it appears like they might be similar because we have this one that's congruent to this one. But how many degrees is this one? So this must be 30 degrees in order for these two things to be similar. All right, so we're going to use 180. We're going to subtract this degrees, which is 102, and we get 78. Then we're going to subtract our 50, and we're going to get 28 degrees. And so we figured out this angle has to be 28 degrees. Well, is 28 degrees the same as 30? Definitely not. So these are not similar. Okay? All right, the other way of determining whether or not triangles are similar is looking at their sides. So remember, the corresponding sides need to be proportional. So basically what it's saying is, oh, if we take this side, LF, that's 15, and put it over its corresponding side of 30, we can reduce that to 1/2. Then if we take this side, which is 25, and put it over this side, 50, oh, I did the bottom one. Oh, well. That is also 1/2. And then 20 divided by 40 is also 1/2. So since all of these sides are the same scale factor, so remember, this is called your scale factor. So they all have a scale factor of 1/2. So this one is half the size of that one. And so they are similar. Not congruent, but similar. So we can do the same thing here. We're going to go ahead and take all of our sides. So I kind of just start with the smallest number. So I know the smallest number here, which is 4, is going to go over the smallest number of 5. And that has to be equal to the next number, which, let's do this one, 6 over your 7.5. And our longer side over the longer side, so 8 over 10. And so I know this one right here is pretty easy. You just reduce that by 2, and you realize that is 4 over 5. This one might not be as easy to tell, and that's why we have good old Desmos as your scientific calculator. So if you use Desmos as your scientific calculator, and now I forgot what it was. It was 6 over 7.5. Okay, let's go back. So if we're going to type that in, we're going to 6 divided by 7.5, and it gives it to you as a decimal, but if you click right over here, it'll give it to you as a fraction, which is 4 over 5. And so when you divide those, that is also 4 over 5. And so, yes, these triangles are similar because the sides are proportional. That means they all measure the same amount. All right, so here's one where it's not similar. Obviously, I'm telling you the answer already. So we're going to go ahead and take this, 10 divided by 15, and that's got to be equal to the 6 over 9, and that's got to be equal to 8 over 14. We're going to go ahead and reduce all of these. So I know 5 goes into the top and the bottom. Whoa. And so that's going to be 2 over 3 when we reduce it. Hey, the 6 over 9, I know that 3 goes into both of them, top and bottom. We're just reducing those. And 6 divided by 3 is 2 over 3, so that reduces as well. And then the 8 over 14, I know that can be reduced by 2. And so when we reduce it by 2, that's going to be 4 over 7. And obviously that is not the same as 2/3. So 4 over 7 is not equal to those two. So these triangles are not similar. All right, so here's what you're going to do now. You're going to go ahead and when you go to your little worksheet, your Google slide, the first thing I want you to do, I'm going to zoom in. So if you go over here, you're going to go to 100. And you're going to just look at these, first, you're going to just look at these two triangles. And some of them are pretty obvious. Hey, that one's 45. Is the other one 45? No, so it's not similar. Where these ones are not as obvious, you actually have to find. So hopefully you can click in there and delete that degrees and actually find it and type it in yourself. I just randomly did it. So hopefully you can actually go in and type in once you find those measurements and then determine if they are similar or not. And then, so you just kind of fill out those purple boxes. And then when you go here, I'm going to go ahead and go here. These are the same slides as that. So this triangle is the same as this one. So then you determine, oh, this one is not similar. So you're going to just drag it over here. You might have to make it smaller so that they all fit. But you're just going to go ahead and organize these and make a column one where they're similar and the other side that is not similar. Okay, so hopefully that helps you when you're doing your worksheet. And it helps you practice whether triangles are similar or not.